Hi everyone, it is September 8th and I feel like I did a really bad job today in class talking about nodal analysis. I think the example was too hard. I have been trying to give you more examples, but I feel like to understand concepts sometimes you need a simpler circuit. And I was going to show you a very simple circuit, but it turns out I already made a video many years ago about it, so I'll just post the link. So this would have been my second example, and turns out it's going to be second simpler than what I did in class. And I also want to talk about drawing circuits that are not straight, that have curves or things crossing someone else, some other branch. It's totally okay. You can redraw the circuit then straight, and it works the same way. If you have to solve any circuit that's nodal analysis or mesh analysis, you can first combine resistors. In this case, even though this is a huge node, it looks to me that the question is on IA, and this is the current being measured. You could say that this current will be the same current that goes into the combination of these two 8K resistors that are in parallel. They share these two nodes here, so this and this, and therefore they're in parallel, and the 2K and the 3K are in series. So I will draw this in a little bit better way for me to see it. So 8K in parallel with 8K is 4K. And then 9 milli here. And then 5K. Now what happens is that the 5K and the 4K are in parallel. So I can further simplify this, but instead I'll just leave it there. And I will apply the steps to nodal analysis. And I simplified this here. In class I wrote a whole page of these steps, but the first step is find ground or define ground. So I'm going to use yet another color and say, so this node only has really these two components. This node has everyone, so I'm going to call this guy here, this node here, ground. And now I'm going to label everybody else, and I'm going to label, I'm going to label nodes and currents, because none of these are labeled. So I'm going to label this A, and I'll label this node B. This circuit has 3 nodes, 1, 2, 3. Well, here it had many more nodes, but now it has 3 nodes. And it has no current supplies. So no current supplies, I go to the fourth step. But I just want to say that it has 3 nodes. And if I use one as ground, that means I need 2 KCL equations. If I had 3 nodes and 1 power supply, 1 voltage supply, I would only need 1 KCL equation. So I'm going to write KCL on A. Oh, I forgot to label these currents. And I'm going to label some to the right, some to the left. So I'm going to say KCL on A is no currents coming in equals currents coming out, I1, I4, and I5. Minus 3 IA. Whoops. IA is I4. So this IA here ends up being here IA divided by 2, and this IA divided by 2. So when I combine the two, it's IA. IA equals I4. So 0 is I1 minus 3, I4. And now I'm going to do KCL on B. And on node B, there's I4 coming in. There is 9 milli coming in, and there is I5 coming out. So this here was my step 4. And I'm gonna go to step 5, which is Ohm's law for these currents. And I want to define I1, I want to define I4, and I5. So I1 is going to be VA divided by 1K. I4 will be minus VB divided by 4K. And I5 is going to be VB divided by 5K. And finally, I'm going to make the system of equations. I hope you see how much simpler this is than the example that we did in class. Yeah, I felt pretty bad after class today. So I'm hoping to remediate it with this video. Now you see I have VA and VB as the only two variables for Ohm's law. But now I'm going to rewrite these equations here, these two equations. So in these two equations, I had 3 variables. And then you couldn't really solve this with I1, I4, and I5. There are 3 unknowns. But now we're going to rewrite them with Ohm's law, and we're going to have only 2 unknowns. I'm going to put the 0 on the other side, and I'm going to write I1 minus 3, I4 is 0. And instead of I1 and I4, now I'm going to write this, VA over 1K. And I4 is minus VB, so it's going to be plus 3 over 4K VB is 0. And then the second is I4, and I'm going to put the 9 milli on the other side. So this I just swapped I5 and 9 milli. I4 is minus VB divided by 4K, and I5 is minus VB divided by 5K is minus 9 milli. So now, of course, we can solve the second one for VB. And then substitute on the first one. If we had 3 equations or more on the exam, I will require you to write a system of equations. So I'm going to give you an example of the system of equations here. So it's AB times VA and VB equals, which is going to be 0 and minus 9 milli. You could multiply everybody by K here. But for now, I'm just going to say VA divided, it's 1 over 1K. And this is 3 over 4K. And this guy is minus 1 over 4K minus 1 over 5K. And this would be the answer on the exam that you would leave, which means I can easily reconstruct this first equation here. This times this equals 0, and these two coefficients times V and VB equals minus 9. And you also have only 2 KCL equations, and then this here has 2 unknowns. I don't know if you can see that. Oh, do I write? I'm not sure I wrote unknowns right there. I hope you can see how a circuit like this or like this can be solved by finding VA and VB in this way. So given that this is 0, I would define these two voltages here very easily. Here, for example, but I'll leave to you to find VB and VA. And finally, after you find VB, you can find I4 and IA. So I4 would be minus VB divided by 4K, and you would be done finding IA.